launched the wing and the wings weren't perfectly aligned with it, it could veer off into some direction or crash. We really had to take the wing off exactly into the wind. And once the winged UAV got into the air, we maintained a fixed altitude. Then we started banking towards the tornado, following the inflow to kind of help us with that flight. And then for stage 3, we dropped the quadcopter from the bottom of the winged UAV, and then that's when we would fly into the radius and maximum winds. And now Tanner's going to take it from here and talk about the plane setup.
Yeah, so obviously it's not super easy to build a plane that can fly a drone to a tornado. So while this plane looks like kind of any old radio-controlled plane on the outside, all the internals are pretty much the highest performing electronics you can buy. The batteries specifically are pretty much like best in the world, and we use 20 of them. And we have like the motor propeller combo that we use on this. We did the math on, and it's definitely not what's like usually used on this airframe. But that let us get around 40 meters per second flight speed, which is around 90 miles per hour, and we could do that for 30 to 60 minutes. And we had a max range similar to the quad of around 10 kilometers. Everything on the inside was waterproof as well, and we also have autonomous takeoff, return to home, and stabilization. So what we can do is we can just take the plane out of the car, we can flip a switch, and we can throw it into the air, and it's going to take off, and then fly in circles around us until it's ready for us to take over control. Obviously super helpful in like such a chaotic environment as it is around a tornado. This also has all the same sensors as was on the drone, as well as a 360 camera, which we added later on in the deployment, and we'll show that later. Okay, so the way we did sensors is kind of different from how sensors have been done on drones in the past. We actually integrated all the sensors into the flight controller. So the flight controller is running custom code that is reading temperature sensor, humidity sensor, airspeed, pressure, and it's able to display that on the video as we're flying, so we can see a live view of what our sensors are reading as we're going towards the tornado. And we record the video. We also record all the data onto the SD card on the drone, as well as we are live streaming all the data back to the ground station computer. So we used a lot of open source software to achieve this. This is the great thing about open source, is that people over decades have developed really great performing flight control software, and then we were able to add all this tornado specific stuff on top of this. So we were able to add all the sensors into both Autopilot and Betaflight, which if you fly racing drones you might be familiar with. We also have a custom communication protocol that we used specifically for tornadoes. And then on the ground station itself, we use Python and Node.js to basically just store all the data, as well as we had other things like the plane was able to flip the switch, and then it would autonomously follow the car. So if there was other stuff going on, that was no problem. Okay, so ground station. Basically, everything would come back down to us from a tube antenna that was mounted on the dash, and we were able to parse that data coming in, and then we did stuff like what we did here. We were able to take the GPS location of the plane and actually spoof the GPS, and then have Radar Omega read that. So Radar Omega was able to read the location, or show the location of the plane on the map.
All right, so for our mission in May of 2024, our objective was pretty simple. It was just to prove the concepts that we could fly a drone inside of a tornado and gather data. So in February, in very late February, the idea was born. Reached out to Tanner, and then the three of us got together. In March, we did a lot of the designing and R&D. And in April, we did some final planning, and we were able to get Eric to join us as our chasing guy. And then in May, we did our 2-week field mission from May 11th to May 25th. So we're going to get into that pretty shortly. And just before we get into that, I know there might be some questions about this, but we have had extensive talks with the FAA over this, and we do have full approval for our project. We've done a lot of behind-the-scenes work on this. We have ops manuals, SRMs, and all that as well. So this is our first test day.
Yeah, so the first test was super nerve-wracking for us. I had built a plane and Lou had built a quad, and we had never tested them together before, and we had spent tons of money to come out of the plane, and we pretty much had no idea until we threw the plane in the air, and if it didn't work, it would hit the ground and probably be in pieces. So this is how that went. So luckily the plane had a pretty successful takeoff.
And this is what it looks like from my perspective underneath the wing. So I'm actually viewing the world upside down. And then eventually Tanner drops me, I get my bearings, and then I'm able to stabilize and fly off. So this was that first deployment. So we had no idea if this whole concept would work until that happened. And then from there, you can see me just following the wing. And it was beautiful at that day.
And Eric had a camera ready in case of crash.
Yeah. And this is a little speed test that I did on the field just to see if everything was working order. And it flew really well.